Good morning, students. Let us proceed our chapter electricity. And today we will study the experimental verification of Ohm's law, which is very helpful in your practical session as well as theoretical session. Now you see here, we have drawn one circuit diagram. I am showing you circuit diagram. This is open plug key. Next cell, we know minus and plus two terminals are there. This cell is connected to ammeter. You know ammeter is a device which is used to measure current. This ammeter is connected to one resistance and then again voltmeter. Students, you are knowing that voltmeter is always connected parallel because it has very high resistance. So to lower down its resistance, we are connecting it parallel. Ammeter is always connected in series. Students, one thing you always remember whenever you will check the circuit, positive terminal of ammeter is connected to positive terminal of cell. If this one you will remember, then everything it will be easy. And then it is connected in series. So see this plus minus. This plus is cell plus is connected to positive terminal of ammeter, minus, then again plus minus, voltmeter is parallel, and we have taken one rheostat. Rheostat, students, you are knowing that it consists of variable resistance. Ohm's law we know V is equal to IR. So let us give some known variable to V and calculate the I. And based on these two, we can calculate R. So let's start. When we switch on plug key, current started flowing. So first of all, don't forget to show the direction of current, positive to negative. Rheostat, just you slide this one at this point or this point, right or left. So better you will start from right only. So first of all, this should be this at this notation, this point. As it is showing this point, that means we are taking some known value of potential difference, and by that known value of potential difference, we calculate the value of ammeter. So one data just I have shown you. If we are taking the voltmeter reading as 0.6 volt, current we have got 0.3 ampere. And when you calculate the resistance R is equal to V by I, you will get the resistance as 2 ohm. Again, with equal difference, we are increasing the potential difference. In this case, students, one thing also you remember that voltmeter or ammeter, its resistance varies with temperature. We have studied that factors on which resistance depends, and we also have studied that resistance is directly proportional to temperature. So if temperature increases, resistance increases, and it will give another values. It will not give the right value of R. So for this case, what we have to do? First we plug in, take first value, then plug out. No current will flow. It will cool down and take 30 seconds, 40 seconds. After that, again you plug in next reading, suppose I have taken over here voltmeter reading 1 volt. By seeing this, take the ammeter reading, that is 0.5 ampere, and calculate the resistance R is equal to V by I. Again you will get 2 ohm. Again next step, you plug out, so that nowhere in the whole circuit the temperature will increase and it will not vary the resistance. Again you plug in, and suppose here I have taken 1.5 volt. So ammeter reading you will get 0.7 ampere and you will get the resistance 2.1 ohm. Again plug out. Take 30 seconds, 40 seconds or 1 minute. It will be okay. Plug in. Current starts flowing. Suppose here I have taken 2.2 volt. Current we have got 1.1 ampere and again resistance we have got 2 ohm. So students, like this we are doing experiment in our lab, and you will also do that when school will reopen. Let us see when this opportunity we are getting. But whenever you will write the experiment, it is based on this only in your lab manual. Now when you will draw the graph of this Ohm's law, I hope you are remembering x-axis, y-axis. X-axis is for independent variable, and for V and I, independent variable is V. So V is taken in x-axis, I is taken in y-axis, and when you plot this graph, you will get a straight line. This is Ohm's law. So based on this, let us calculate one numerical. See the question. The potential difference between the terminal of an electric iron is 240 volt and the current is 5 ampere. We have to calculate resistance. So students, see here, first of all we are writing given. V is given 240 volt. I is given 5 ampere. We have to calculate R. From Ohm's law we know V is equal to IR. So we can write it as R is equal to V by I. What is R? V. V is 240 and I is 5. So when you will calculate this, you will get 48 ohm. So value of R we have got 48 ohm. Like this we can calculate the different questions. So one more question I will show you. See the question. A wire of length L and resistance R is stressed. One wire we have taken whose length is L, we have stressed it, and its area we have just half it. So you will see this, so that length doubled and area of cross section is halved. So condition is given, you have to show how its resistance changes. So let's see, we know the formula of the resistance, that is for first case, case 1, length double. As the length double, we write this one as, for L it is 2L and for area it is A by 2. So formula we are knowing for this one is R is equal to rho, this is new resistance, so let us write R new, rho L, L is 2L, by A, A is A by 2. So here what we will get it? Rho L, L, and here it is 2, so let us here take it 2, by area, area is just like this, area, and this will go upwards, that means 2 into 2. So we can write this as 2 into 2, 4, rho L by A. Means rho L by A is the previous resistance, we know the formula, and new resistance we get it, that is R new is equal to 4 times the resistance. That means the resistance increases 4 times. New resistance increases 4 times. So let us see then what happens for this resistivity. We know that resistivity does not depend upon the material, that is its length or its area. So resistivity does not changes. So for second answer, here I am writing resistivity does not change. It will remain same as for resistance because it does not depends upon the length or area or of material. Okay, so revise this numerical.